Sequences are an ordered list of terms, a series, a sum of terms. When they are arithmetic, then they have a common difference d that separates them. So to determine whether each sequence could be arithmetic, you have to look to see that they have a common difference d. So yes, d is 6. Here shown another way. And now we could use d of 6 to go from the last term of 14, add 6 to get the next term of 20. So in review, negative 10 was a sub 1, negative 4 is a sub 2, and to get there, we add 6, and to proceed, we keep adding 6 until we get to the 1, 2, 3, 4, 5, a sub 6th term, which will be the previous term of 14 plus 6 to get 20. In the next example, we find out pretty quickly that it is not arithmetic. The first difference is negative 3, or I subtract 3 to get from a sub 1 of negative 2 to a sub 2 of negative 5. And then from a sub 2 to a sub 3, I have to subtract negative 6. So this is not a common difference d, therefore this sequence or list of numbers is not arithmetic. To forecast to any term in an arithmetic sequence, use this formula. It's easy to derive. Looking at this arithmetic sequence, we could take the first term, which you do not need a common difference d to create because you start there, and then the number of terms minus 1 additions of the common difference d is used to generate the terms. So that's why you see n minus 1 here multiplied by d and added to a sub 1 to find the a sub nth term. Please keep in mind that n is the number of terms where a sub n is the nth term. In the next example, we want to find the 12th term. We could take our time and keep, like after we find the common difference d, add it one after another, but that's error prone. We might make an arithmetic mistake, but also what happens if it was the 300th term? So we'll use this formula after we pick out the following information. I know which terms that I need because the formula tells me. First, I need a sub 1, so that's 20. And then I need a common difference d. So I take a term and subtract it by its previous term to realize that I'm subtracting 6 to get from every term to the next. Now this n is the 12. So substituting into the formula, following the order of operations, inside the parentheses we do the difference of 12 and 1 to get 11, and then multiplication before addition. 11 times negative 6 is negative 66, and that combined with 20 gives the 12th term of negative 46. We will now use the same concept of arithmetic sequences and remove consecutive terms, hence the use of the word means. In order to set up these problems, you have to read the directions carefully. We are asked to find the 3 arithmetic means between these two given numbers. So we're missing 3, and these are the beginning and the end of this sequence. That sets up the following sequence, where we leave gaps for the arithmetic means in between. Distilling this information, we see that a sub 1 is 17, starting to put the given information into the language of the formula so that we could use it to figure out these unknowns. And then you count the first plus the 3 in the middle plus the 1 on the end, or 3 plus 2, gives you a total n equaling 5, where negative 7 is the 5th term. Substituting this information into the nth term formula for arithmetic sequences, we get the following. There is something really important to point out here. The subscript of the term that we have this equal to on the left, a sub 5, that number of 5 must equal the n in the formula. Even more subtle is that the subscript here for this term of a sub 1 must match this number here. We will get more into that in a problem soon. Substituting in the information and solving gives the following value for d. So notice we have one unknown in this equation that we could solve for, and d is -6, which we will now add to 17 to get the first of the 3 arithmetic means, and we'll continue that all the way and until we get -7 just to check. We have 11, 5, and -1 as the answer. Everything else was used in finding it, so only box what I have here in purple. Now that we saw that we could use the nth term formula for arithmetic sequences to find the value of d when given 2 non-consecutive terms in the sequence, we can now work with 2 values, find the value of d, and then use the nth term formula to find a particular term of interest. Step 1 is to find d. So what I've done here is I've used color coding to point out how these terms have to be the same, and in the context of this problem gives the following. The subscript of 14th for the term that appears later in the sequence is here on the left-hand side of the nth term formula, and so that n value here is 14. These need to match, and then instead of starting with the first or a sub 1 term, we're starting with a sub 8, and that's why this is now 8. And to get from the 8th term to the 14th term, you need 14 minus 8 copies of d added to the starting term. Substituting in the numbers, we get a d value of 12. Carefully again using the order of operations, 14 minus 8 is 6. Substituting in a sub 8 of 85, a sub 14 of 157. Now I subtract 85 from both sides, so if it's positive on the right, then it's negative on the left. From 157 I get 72, and then I divide both sides by 6. The next step is to find the indicated term. In this problem, it's the 5th term. So I have the formula here for your reference, and now I'm going to carefully substitute in and make indices match. But you'll notice that I need to pick if I want to start from the 8th term and go back to the 5th, or from the 14th and go back to the 5th. Either one will work as long as you make subscripts match. The 5th term that I want to find, I put on the left, and then I choose which term I'm going to start with, in this case the 8th, because that was closer, and that'll keep these numbers difference smaller. And notice you have to go in this order. So yeah, I'm going to get a -3 here. That makes sense because I need to go left, and if I have a distance value of 12, a common difference of 12, then that means I added 12 3 times to get the 8th term. So now I need to subtract 12 3 times to get back to a sub 5. Simplifying gives us a 5th term value of 49. We now transition to the last section, arithmetic series, where series means sum, and in this case of the terms in the arithmetic sequence. So for the first n terms, it's the following formula, where s for sum of n terms, sub n, is equal to the number of terms n on 2 times the sum of the first and last terms. Gauss, as a little boy, as the story is told, figured this formula out in a very short period of time when his teacher, hoping to buy some time to do some grading and keep the kid from asking so many questions, because he was eager to learn and was very smart. And so the teacher said, go and sum the numbers between 1 and 100. Much to that teacher's dismay, as the story goes, Gauss comes back within a very short period of time with the answer, and through that experience, derived this formula in the following way. First, Gauss listed the numbers from 1 to 100 in the following fashion, using ellipses in the middle. He proceeded to write the same sum, but in reverse order, carefully lining up these terms. And now we could start seeing Gauss's breakthrough. When doing this, we realize that we get 100 identical terms of 101 in the sum. So if 1 plus 2 plus etc. up to 100 is equal to the sum of interest, and then we are adding it to itself, we have twice what we need. So we could rewrite all of this as the following equation. We have 2 sums s is equal to 100 of these 101 terms. Dividing by 2 and multiplying gives an answer of 5,050. And that's how this formula was born, and we will now use it in the following 2 examples. The formula for these problems is very easy to use, but you have to know how to extract the needed information from the problem because they could be set up in different ways. For this first example, this subscript cannot be ignored. That 18 means we are summing 18 terms, the first of which is 13, and the last we don't have. But we have a formula that finds the nth term, so these types of problems often will require more than one formula. So before we could use this formula, we have to find that missing piece I brought up, which is that nth term, a sub 18. So there's step 1, picking out the info that I just mentioned. Step 2 is to find the nth term using the nth term formula, substituting in, and simplifying gives us the last term that we need to include in this sum of 18 terms. So the third step is now to find that sum using the sum formula. Substituting in, notice it is the sum of the first and last terms, and we're adding a negative, which gives negative 161 multiplied by 9 for the following sum of negative 1,449. Does that sum make sense? Yes, we start off with a couple positive numbers, but the rest are all negative, so we should expect a large negative sum. The last problem is a little more cryptic in the way that information is presented because it's more concise. So we have to know what we're looking at and what we're looking for. Our goal is to find out how many terms are in the sum and to extract what the first and the last terms are. In summation notation, we are starting with the index of summation k equaling 1, and you substitute that in to the formula where k is, so then that would produce the first term, and then you would go to the next consecutive integer of k equaling 2, and you would substitute that into the formula, and then you would add that to the first term, and you would continue that process until k is equal to the top number of 15. So to find out the total number of terms, when you start off with 1, it's always the top value, but if you start with a value at the beginning that's different than 1, you always have to do top minus bottom plus 1. As advertised, that gives an end value of 15, but don't forget that formula. And the reason why we add 1 is because let's say we had a 3 up here, to always look at a smaller case to understand something. So I would substitute this in once, twice, and then a third time, and 1 plus 2, or 1 plus 1 plus 1 is 3, but if I do 3 minus 1, that's 2. So with subtraction of actual objects in a list, you have to add 1. To find the first term then, you substitute in the initial value of the index of summation into the formula, And then to find the nth term, in this case 15, a sub 15 is when you take the top number and substitute it into the formula. Those values are 7 and 35. So now we have all the missing pieces for step 2 to find the sum. There's the formula. I make the subscript of s equal to n of 15. That number matches the numerator on the right-hand side. And then I substitute in for the sum of the first and last terms. 15 is odd, so it's not evenly divisible by 2. So with hopes that I won't have a fraction, I sum inside the parentheses. 7 and 35 give me 42, and now I could divide out the 2 evenly and then multiply 21 by 15 to get the sum of these 15 terms to equal 315.